Nagesh.
Sir, let me start, sir. Ma'am,
Okay.
ma'am, welcome, ma'am.
Thank you.
Shall we start, ma'am?
Yeah. You expect some more participants to join?
Yes, ma'am, but it's already
Almost to
2:10,
10.
ma'am. So
Yeah.
some people may join afterwards.
Okay.
Yeah,
Okay.
already 23 members joined, ma'am. Till some more people have to join.
Okay.
They join within 10 or 15 minutes, ma'am.
Okay. We can start. I'll let them join afterwards.
Okay, ma'am. Thank you. Good afternoon to all. This is Maheshwari from Kongu Engineering College. I welcome you all for the third day of Faculty Development Program on recent trends in deep learning techniques for image processing application. We are very much happy to invite our beloved HOD ma'am, Dr. R. Meena Kumari. Welcome you, ma'am.
Thank you.
I take immense pleasure to welcome Dr. P. Kiran Sree, speaker of today's session. I welcome you, sir.
Thank you, madam.
And I welcome all the participants from various institutions for showing keen interest and active participation throughout the session. I welcome you all once again. Now I would like to invite our Meena Kumari ma'am to share her views. Thank you. Meena ma'am.
Okay, I'm on the line. Okay. Thank you, Magesh. Now I'm happy to welcome you, Kiran Sree, Dr. Pokkuluri Kiran Sree. He's from Andhra. Now I'm just amazed when we raise a proposal. I got a proposal raised from Dr. Mageshwari. Why can't we conduct a faculty development program on this deep learning for the electrical engineers? Yes, I accept. No, to start with, I just a little bit worried. No? So, what could be the response? How this area is applicable to engineering problems? So, when I just go into the details of the lectures delivered by the eminent persons on this last 2 days, I was really accept that this is the new area where we have a higher potential for the researchers. And the third day, the guest speaker is the up to person to discuss on this particular this deep learning. So I really happy to have Kiran Sree here. He completed his BTech and ME in Computer Science Engineering from JNTU and Anna University, and he received his doctorate in the area of artificial intelligence from JNTU. Now he has authored about 6 books in UG and PG students of engineering in the area of artificial intelligence, and more than 80 plus research articles he has published in various national, international journals and conferences. So he has 4 patents in the area of deep learning. Okay, so it's really very an amazing thing to have a very eminent person for this today's session, and I'm very happy to welcome again Professor Kiran Sree. So Kiran Sree, I'm very happy to invite you and the session.
Ma'am, your voice is breaking. I think so, ma'am.
Is it audible now? No.
It's audible, madam. Please go ahead.
Oh, okay. Actually, his bibliography is published in Marquis Who is Who in the World, which is a very reputed publication where we find a minimum number of people from India in this 29th edition in USA. And he is the recipient of Bharat Excellence Award from Dr. G.V. Krishnamurthy, former Election Commissioner of India for 2 times, and recipient of Rashtriya Ratna Award. So he was the BOS member of CSE and IT in the universities and autonomous colleges, and he also worked as principal of the NBKR Institute of Science and Technology, which is the second oldest private engineering college, for 2 years. So he has got 18 plus years of experience and working as professor in the Department of CSE at Sri Vishnu Engineering College for Women, Bhimavaram. Now he is professor and working in Bhimavaram. And So we are very happy to have you, Kiran. And now the forum is open to all. And I hope this session is going to be a very wonderful session. So I am also listening to you. Professor, you can take over the session.
Thank you very much, madam, for such a wonderful introduction. And it's a privilege to be part of this faculty development program on recent trends in deep learning for image processing applications. I have to thank the principal, Dr. Abalum Swami sir, and the head of the department of EEE, Madam Meena Kumari madam, and in particular, Madam Dr. Maheshwari madam, for giving me an opportunity to express myself on various thoughts and insights of deep learning and artificial intelligence. It's also a privilege, like I wish to share, like I have authored a textbook for deep learning for Pearson education. That is most probably by the end of this month, that book will be out in the market, madam. The title of the book is Deep Learning and Its Applications, and it was published by Pearson Education. And particularly the title that I have selected for this particular FDP is very apt, as Gartner has recently released his top 10 technologies that can disrupt the world. The first technology that he has mentioned is artificial intelligence and deep learning. So obviously, knowledge in this deep learning and artificial intelligence is the most important thing, because most of the open problems, deep learning is not pertaining to a particular area, whether it is computer science or EC or EEE. It is now deep learning applications are everywhere. People are using it in a mechanical domain. They are using it in EEE, EC. Many places they are using this deep learning. So I feel this title that I have selected, the recent advances in deep learning, is apt for this FDP, because we are living in an artificial intelligence world where AI has become an integral part of our life. So with this small introduction, I will just try to share my screen, madam. Madam, are you able to see my screen, madam?
No, sir.
No, just I think must be.
Yes, sir, we can see.
Now it is coming?
Yeah, it's visible.
It is visible. Okay. So thank you very much. The title that I have kept it for this today's session is Recent Advances in Deep Learning. This will become a subset or a part of the book that I have authored recently. Like I have authored a textbook on deep learning and its applications for Pearson education. Most probably the next week that will be in the market. So most of the inferences, most of the discussions that I have taken from the textbook and I kept here, and some of the relevant aspects of modern era also have kept in these slides. And this is how I have organized the slides. Like I start with various artificial intelligence and deep learning mechanisms, and followed by the most important deep learning applications that we have now. And then we'll see what are the differences between traditional systems and AI systems. And then we'll see the overview of machine learning. And since the advent of machine learning, why we need to go for a deep learning. If possible, we'll also see a case study and just conclude. And going to this first slide of my presentation, like we have many definitions for artificial intelligence as well as deep learning. Every time when you try to design or implement systems in AI, we try to have any of these four different types of mechanisms or in a combination. So the first one that I have mentioned here is, can we design systems or can we develop systems which exactly thinks like a human being? It's very difficult to replicate a human brain. So that is the reason Thinking humanly, this objective is the ideal objective. It's very difficult to achieve. The second one, that one of the mechanism that we can achieve is acting humanly. Can some of the mundane tasks that are done by a human beings can be done by a system in a better manner than by human beings? It is something like it is study of how computers do things at this moment. People are doing better. So mostly, since it is the way in which you train the system to mimic the activities of the human being, this objective can be achievable. And if you see the applications of AI, most of the applications of AI will fall into this acting humanly category. And thinking rationally is the third aspect that I have kept here. Can can the systems can think logically, or can we use computational models to design things? It's very difficult objective to achieve because it's very difficult to train the systems to think logically instantly until unless it is trained. So this objective cannot be achieved. So we can achieve this objective to some extent in the ratio of 20%. And the next objective is acting rationally. Can we design a system which exhibits some intelligence? Or can we design intelligent agents? Can we design a computer which exhibits intelligent behavior? This objective can be achievable. So most of the AI applications, whether we discuss about Sophia, Tesla, whatever applications that we discuss in the terms of deep learning or artificial intelligence, they will fall mostly in these two categories. So your AI enables the machine to think, and it will try to mimic the activities of human being, and it will train the machine to think and to take some conclusions. So we could understand the advent of artificial intelligence and deep learning that will come in the next slides very clearly. So you could see here, I have kept a Deep Blue system that was developed by IBM, where Deep Blue is a chess playing system that has defeated the world champion Gary Kasparov in 1997. The idea is when people try to think the implementation in the terms of AI or deep learning, they will try to implement these games. Like chess game is a game where you have 64 squares, where 16 and other plus 16, 32 pieces will play. They will move from one state to other state based on some constraints. But the challenging aspect is, can you design a strategy to predict how the opponent plays? So every time when you try to write a program to play a game, whether it is a chess game or most of the people know this type of game, like people call it as a tic-tac-toe game, where two players will play a game like this. So whenever we try to design an AI application or a deep learning application to implement this type of games, whether it is a chess game or a mini game or a tic-tac-toe game, we need to predict the way in which the other opponent will play. Based on that, we need to win or we need to go for a draw. This is what the importance is. So I have kept a very old system that is developed by IBM that is called as Deep Blue. Deep Blue is a chess playing system that has defeated many world champions of chess. And at the same instant, in the same slide, I have kept a latest AI and deep learning technique we call it as Tesla. Tesla is the name of the company which manufactures car, where 70 to 80% of the entire technology is a deep learning technology. So Tesla produces cars, self-driverless cars, semi-autonomous cars, and the most important thing is when it is moving from one state to other state, when it is in a motion, it has to think about the left neighbor, right neighbor, the front neighbor, and the back neighbor. Based on that, it has to move. So how does a driverless car can move based on the learning aspect that it will learn from the surroundings? Like the futures of Tesla are, we can say like it is lane centering, adaptive cruise control, self-parking, automatic lane change, and many other aspects are there. But the interesting thing that I need to tell you here is Tesla used a deep learning mechanism to process the videos at real time, and it needs to find out when it has when this Tesla, when a self-autonomous car has moving from one state to other state, it has to think about all the surroundings, and it needs to also find out when it is going to park a car, it needs to find out the amount of space that is available, whether it is sufficient for this car or not. So most of the applications that we see that are prevailing now are all the applications of deep learning, most of them. So deep learning is the most important technique that Tesla is using, whether to process the videos, to process the images. They use CNN plus RN in a combination. So you could find many other applications of AI. In particularly, whatever applications that I have kept in these slides are applications that are pertaining to deep learning. The emphasis most of the time they are. The slides are prepared in such a way that the recent advancements of deep learning was kept in mind. So most of the people heard this term called as Sophia. Sophia is a humanoid robot. The interesting thing is the Sophia can give human-like expressions. It can interact with people. It can talk. It can give or represent some emotions. It can also give some facial expressions also. We could see here, Sophia is taking a class for 8th class students. The interest of keeping this slide is how does your Sophia, a robot, can process the voice real time and answer the queries of the students. An interesting feature of Sophia is it can understand sarcasm also, the type of laugh that people will have, and it processes the images live, and it will also give the same expression, facial expression corresponding to whatever expression that we give if it is trained. So Sophia is the most important application that I can name it when deep learning is concerned, because Sophia processes voice, it processes video, it processes images to react to the corresponding situation. I said it can give human-like expressions, it can interact with people, it can give few facial expressions that are trained. So many versions of Sophia now. Sophia is every day. Sophia is getting a new feature that is added to her, like taking a class. And now Sophia is trying to give virtual lectures in deep learning also. We could see that information in MIT website. Another important application that I have mentioned here is Mycin is an expert system which takes the input from users. Like I said, I am suffering with headache, I am suffering with backache, and I have a running nose. What may be the output of this? What may be the disease that is attributed to these symptoms? So Mycin can give automatically. If Mycin was given are trained with a DNA sequence of your body, Mycin also will analyze the DNA sequence and it will tell you what type of diseases that you can get in future. Apart from it, you can give also, after processing this DNA sequence, like what type of, is there any chance that you can get a cancer, what type of cancers you can get. So Mycin, a link can be found in WHO. Now Mycin is assisting various doctors to prescribe medicines without any side effects. Apart from that, Mycin has almost different types of functionalities. It has more than 400 different types of outputs it can give based on the input that was given. Earlier, Mycin used to interact with people in the terms of text. Now Mycin is interacting with people in the terms of voice. So now, whenever you wish to develop a AI system or a deep learning system, the prerequisite of that system is to process the voice and understand the input from the user. So now the Mycin is able to process your voice, and it can just tell you this may be the probable disease that is attributed to the probable information that was given or the symptom that was given. So Mycin is the most important application that uses both standard machine learning techniques. Now it is using a deep learning mechanism to analyze even the X-rays of people who are convicted to this COVID also. So many other different features are there that will come in a later stage. So all this is a slide which will tell you like AI is everywhere. Like AI, we call the software that in cricket as a Hawkeye. Hawkeye is the most important application of deep learning. The reason is every time when the ball is pitched, the amount of deviation that the ball will take, the amount of displacement it will take, and the amount of height it will travel after pitching is very difficult to predict in real time. So your Hawkeye will process the video in real time, and it will be telling you the how much deviation the ball can take after pitching, the how much of height it can travel after pitching, how much of displacement in the terms of angle it can take. All these are predictions that will happen in real time. So you need to understand, when people try to talk about deep learning or artificial intelligence, they are trying to have a predictor which predicts something in future. So every time when a system is going to predict, the basic thing that it needs to have is a statistical information. Then it needs some dynamic parameters, so that when you add more dynamic parameters, the usability of the system will increase automatically. So that is why this Hawkeye is the most important application that we could find in deep learning, because the videos are processed real time, and it could able to find the displacement of the ball after pitching after some time, something like that. So most of the people know this face recognition is a part of deep learning. I have seen that earlier one of the faculty has taken a convolution neural network in deep learning. So most of the time when people try to think about image processing in the context of deep learning, they will use CNN, convolution neural network. This face recognition is the most important application of AI and DL. The reason is everywhere. Like you use a Twitter, you think about Facebook, everywhere you need to find a similarity of images, whether you go for edge detection or whether you try to have a dimension reduction, all these features. So that can be done very easily in deep learning. Earlier we used to use this MATLAB for this image processing. Now whatever features that your MATLAB is having, now it is also all the features are available in Python, but you need to use most of the DL algorithms will be there in Python in the terms of TensorFlow and Keras platform. So you can use it. So this face learning, face detection is the most important application that we could find in deep learning. Many other applications I kept to just tell you. Most of the open problems, whether you take in the domain of bioinformatics or whether you take in the domain of metallurgy and mechanical, we talk about robotics, most of the important applications, open problems, we have solutions in deep learning. That is the reason I kept these applications of deep learning as a major share that I'm just going to share with you in this presentation. So most important application of your deep learning, I can say it is IBM Watson, because IBM Watson, even though it started its initial version in 2000, it is changing now. And this IBM Watson is a question and answer mechanism where it can interact with people in the terms of text. It can interact with you with respect to voice, and you can also interact with it in the terms of video also. 70% of the IBM Watson is into health informatics. It is a diagnosis of a particular patient, personalized patient diagnosis at the highest level. So I could say, like if you are suffering with chronic disease and this IBM Watson was given a chance to process your DNA sequence, it will tell you whether this disease was inherited from your father or mother. If you are having 6 fingers in the hand, what is the reason for this? If your hair was white since your birth, what is the reason for this? Many other things, like how do you find the protein coding region? How do you identify the promoter region? How can you identify the types of cancers in the body based on your genomics and the DNA sequence that was given? And once you identify, there is a probability that you have something called as the disease that is called as cancer, then what type of cancer, whether it is a bone cancer or it is a breast cancer or is it a blood cancer, it can also give you the detailed analysis that what type of diseases that may occur in future if you continue with the same symptoms and habits. So most of the expert systems, IBM Watson is an expert system which was started designed by IBM since 2001, and it has many versions now. I have listed here a drone technology where I said artificial intelligence is everywhere. That is the reason I have kept this drone technology in this slide to tell you, like we have many applications of deep learning in agriculture also, like what type of crop I need to select for the particular soil, and what type of monitoring strategies I can adopt, because I have published a Sciendex paper which will what does that do is it will predict the types of diseases. It has processed the types of diseases that a wheat crop can get. It has processed by through CNN, CNN convolutional neural network mechanism. It has processed all the different types of diseases that a wheat crop can get, and then it tries to read the leaves of particular instantly, and it will tell you what type of diseases in future it can get. And have augmented this deep learning with IoT so that I can get the instant messages immediately. So it was recently accepted and published in a Sciendex journal. So obviously I just try to tell you many applications of deep learning are possible, and if you just type deep learning in agriculture, many different types of systems will come, whether it is for crop selection or crop monitoring, or whether it is a drone technology which can monitor the crop in life, and it can also spray the pesticides. Many other advantages are there in the terms of how do you train the system and how do you develop the system, what features you need to have. That part is what the strength of deep learning is. And I have intentionally kept some pictures here, like we call this as a Siri, which was developed by Apple. This is called as Google Home. All these are voice processing systems, a most important application that you could find in the terms of artificial intelligence or deep learning. Another important application I have not listed here is Alexa, because all these three can be named in the same category. Alexa is from Amazon, and Google Home is from Google, and Siri is from Apple. But the interest of all these three applications will be something like it is a virtual assistant. Like they can take voice queries, they can answer your queries, they can make recommendations, they can search for you, and they can play music. Like I asked Alexa to play a song called as Telly Pogade, and Alexa has played the song. But the same question I have asked to Google, and it's not able to play the song. At the same time, I asked Alexa to find where my phone is. It's very difficult to find that phone in the terms of Alexa. But same question I have asked to Google, and Google has answered it. So the interesting part that I just to tell you is most of the important applications that people try to develop in deep learning and artificial intelligence, they have to process and understand your voice, because people try to interact with the system in the terms of voice. Now people with 1 or 2 years of age, they are interacting with systems. We can call it as mobiles or any other thing in the terms of voice. So all these three that I have listed, Google Home, Alexa, and Siri, are voice-based systems. We can call them as the most prominent applications of highest repute. Very important because the structure, the way in which the futures, like see, I used to go for a localized search, then I can use Alexa, and I wish to have this searching facility more and context sensitive capability, then I will go for Google Home. So every system will have its own strengths, where you have a lot of advantages for this city also. It depends upon how do you get this. If you wish to have a proper recommendations which are personalized, better to go for city. It depends, but my interest is you need to think about when you try to design a DL system or AI system, you need to process not text initially, but it is voice, which is mandatory for most of the applications now. I have listed here the thing that I have kept here is the home automation. Most of the home automation, whether it is a smart TV or it is a smart fridge or whatever thing that we are using for a smart home, is augmented with deep learning and IoT. Everywhere deep learning was there. You could see here I am talking about a navigation app. We can call it as Google Map, where this Google Map try to adapt itself and train itself to the latest. See, I wish to find out what is the shortest distance between Chennai and Delhi, then what is the current traffic and what way this app is able to get the current traffic, and at the same time it will also get the roads. What is that we have to tell is the way in which the roads are, like condition of the roads. They process the real-time traffic, the condition of the roads, the amount of time it will take, the distance, many parameters it will take, and it will give the output, which is dynamic and it will change with respect to time. So you design AI or deep learning systems which predict something in future and which will happen in future. That is the reason I have kept all these most important advancements in deep learning in the slides. And all this, most of the people, because all our faculty members, most of them know this slide, why I have this deep learning applications, because weather prediction now, weather prediction systems, like you have various expert systems that are predicting weather, and they're telling now that there is a chance that you can get rain at 3 o'clock at some place in Nambur. They are more optimal now. They will be able to tell you the temperature at this moment and the wind speed and rainfall. Like there is a possibility that you have a rain in Adyar at 3 o'clock. So the interesting feature that I have kept here is we have many expert systems predicting the weather. But as I said in the earlier slides, whatever systems that you wish to develop in the terms of deep learning and artificial intelligence, you need to have a statistical data. See, if I have a data of all the weather variations of Chennai for 2 years, obviously I can predict the weather today. But all this data that I have for the last 2 years is called as a static data, and this data will not change with respect to time. But I need some dynamic data, like I need a data which talks about humidity will changes with respect to time. I need some data, we call it as precipitation change with respect to time. I need to get something called as atmospheric pressure at this moment will change with respect to time. I need to find the approximate distance between the earth or your earth to the nearest cloud. It will change with respect to time. So when your AI systems or deep learning systems will be, when they used to process these dynamic parameters which will change with respect to time, then the systems will become more adaptable, robust, and usable. Because AI systems cannot predict when the data is not there. At least they need to have the statistical data. Apart from that, how many dynamic parameters that you process, that much of usability of that system will increase. The accuracy may be decreasing, but the usability, the dependability, the robustness of the system will increase when you add more dynamic parameters, like parameters which will change with respect to time, like humidity, precipitation, atmospheric pressure, the distance between the earth to the nearest cloud. Many parameters will change with respect to time. So all these are very important when you try to develop a deep learning or a system. So we have n number of expert systems that predict the variations of stock market. If I know the stock market variations for the last 1 year in pertain to Reliance, I can also predict what will happen to a Reliance share tomorrow. But see, the stock market prediction, it will change with respect to time. See, I take a stock market prediction change with respect to the political decisions people will take. It will change with respect to the news articles that are attributed in news channels. It will change with respect to the way in which employees talk themselves in the offices, and it will change with respect to the people that they have interactions in Yahoo forums, some public domains, so they are talking about Reliance or any other company. So a lot of sentimental analysis that has to be done to find the variations of stock market. So because stock market will change with respect to the time, the health of the company, the liquidity of that company, the assets of the company, the shares of the company, many other parameters will come. So the many parameters that you process, the accuracy may be some point of time, it may decrease, but the dependency of the people to use the system will increase, adaptability will increase, and that will give you more robustness. So my interest is when you try to have a deep learning mechanism, the most important thing that you need to understand is you need to get the basic data sets which was ready. We call it as statistical data sets. And you need to think about processing the dynamic parameters which are very important, which distinguishes one system from other systems. So all these are very important. So IBM Watson we have discussed in the earlier slide. And if you last year, most probably in March 7th, I have been to IIT Madras to meet Mr. Pondurangan. People are working on CC systems. CC systems are crowd counting systems, or called as expert system. They can process the videos live, and it will try to give the number of people that are there in the video. Apart from that, the most important feature of crowd counting systems is it will also give you the number of people with the different abnormal actions which may cause some harm to the infrastructure, some other feature that was trained. So crowd counting systems are systems which can process the videos straight away. They can take they can monitor the videos of CCTV footages, and within 0.7 nanoseconds they will give you how many people are in that particular place, and it will also tell you what are the abnormal actions and what are the abnormal people with different type of actions which will separate from other people. Probably their intention can be people who wish to damage the infrastructure or something, but most of the people now they are working on automatic monitoring of videos and automatic alert that you get from these videos, because once the system try to analyze the video and it has to alert the administration that this many number of people are there, this is what it's going to happen. And this is what we call it as a crowd counting system, and the most important advancement of artificial intelligence and deep learning, because video processing mostly it was done in the terms of CNN and TNN. We call it as a terra neural network now. So then we have to talk about what type of solutions that people are giving it to address various problems of COVID. If you type COVID-19 plus deep learning, you could find many applications that will come in the terms of COVID to solve in the terms of deep learning to solve the problems of COVID, because people have used CNN that you have in the first session of this FDP to process the X-rays of deceased people, and they try to train the system to predict if a new X-ray was given, how much prone he was to COVID. Is there any chance that is he infected with COVID, or is there any chance that he may be infected or prone to infected with COVID? So many different mechanisms. Almost I have seen almost 17 different papers which has used CNN and combination of TNN, CNN plus RNN to process the X-rays of the patients to predict a new X-ray comes, whether there is a chance that this X-ray is prone or the patient is prone to COVID or not. And you have almost 28 different systems are there, where these systems will see. I have a big enterprise where almost many employees are working in my place. You wish to monitor whether these employees are practicing this social distancing norm or not. You have different types of systems in deep learning now. 28 different types of systems in deep learning are there for some enterprise to monitor whether the employees of that enterprise are practicing that social distancing norm or not, at the same time to alert the administration that this many number of people are not participating. And you have almost 170 different types of deep learning mechanisms are there to just tell you in your an enterprise whether people are following these masks or not, whether the masks are kept, whether they're keeping it properly or not. This many number of systems are there. For your information, both features are there in almost 8 different type of systems. I have seen all these 8 papers, and my interest of keeping all these things is real time. All these papers, all these 8 papers, what I'm referring to are the systems that already came into existence since July itself. So my interest is most of the open problems can be solved by using deep learning mechanism. That is the reason deep learning is the most important technology reported as by your Gartner. Because A and DL is integral part of our life. We are living with A actually. So we cannot subside or we cannot remove A from our lives now. It has become an integral part of our life. So in shopping, when you wish to shop online, you could see the way the systems are trying to find out the way in which you're procuring things. Based on that, they're going to develop a recommendation system where it will just find out what type of commodities or what type of products that you will be able to procure in long time. And see, it will also try to find out the nature of procuring things online, the way in which you're browsing. It will build a bot. It will try to observe your step-by-step way of procuring, try to have a machine learning algorithm on that, and try to understand the needs and necessities that your emphasis is, and based on that it's going to predict and it's going to recommend, and we call it as a personal recommendation system. So the shopping technique will again come in the next slide, and we'll stop the applications of AI with this. So most probably, if you see a news article that was I have read in Hindu last month, Indian government is starting to have e-challan mechanism, where in NH5 most probably that e-challan mechanism is a mechanism where some car is exceeding its speed limit when it is traveling in national highways. You have speed guns that are installed in the highways. They will find out which cars are exceeding the amount of limit that is called as threshold. Then the same car, what is that they do is they take the video of that car by using the CCTVs that were kept there, and the CCTVs will give you the image of the car, and from that image we extract the text which is pertaining to the number of the car, and based on this number automatic email will be sent as per the database says this number has a corresponding email of the owner. It's automatically within 1.1 or 1.2 seconds it will send automatic email to the corresponding owner. But interesting thing is, how does your speed gun and how does the CCTV footage will correlate? At the same time, how does your video in the terms of images, and how does the image is from that image, how you are getting that text, and how do you identify the card number, and how do you get the corresponding email, and how do you send an email automatically. This is what you have done, this is the amount of access speed that you have done in this place, and this is the how much this is amount you have to pay. So all this, if you read that paper, you could understand most of the application that people try to implement now at real time are pertaining to deep learning applications. So you could see, like when you wish to use Amazon or Flipkart, or when you browse various websites of banks, obviously what is that you could see is many chatbots are installed in the banks, where the chatbots will interact with the customers, and they will give the major information that is pertaining to the customers. So chatbot, like most of the time we talk about a chatbot called as Elijah. Elijah is the most important applications of deep learning, where Elijah was trained to find the behavioral aspects of the person, or it will try to give a mindset of the person at this moment. Elijah will interact with the people, and it will ask at least 5 questions. How are you? Are you excited? Something like that. And it will ask you 5 or 6 questions. Based on the way in which you answer the questions, Elijah will just tell you the mindset of the person. So many versions of Elijah are available. Initially, Elijah used to interact with people in the terms of text. Now Elijah is interacting with voice also. It can process the voice, and it can just tell you how you are at this moment. So chatbots can be seen everywhere. You are seeing chatbots everywhere. It's very easy to just develop a chatbot with minimal features, but when the features increases, obviously the way in which it learns has to increase, the way it exhibits the intelligence has to be different. So obviously you can refer many chatbots are there. You can talk about Elijah, or you can talk about Sprinja, or many chatbots will be there in various diverse fields. So many times when people try to have this deep learning, people talk about robotics, because every robot, when you wish to have a robot, like I try to design a robot to move a bench from one room to other room. So then what is that we try to do is we try to find the permissible actions that a robot can do. Once the permissible actions are identified, then we try to code that actions in the terms of productions. Every time when an action is about to perform, we try to give the prerequisites for that rules. Then we try to represent the rules in the terms of implementation. Earlier we used to do it in Prolog, now you are doing it in Python. So robotics, if you see physically a robot, mostly like when you try to design the things and when you try to write the rules and try to implement, that is pertaining to computer science and engineering. But when you try to design the things, like what type of hand it needs, what type of body and structure that we need to have, that is pertaining to mechanical, because it is a 50% mechanical and 50% structure that we will have it in robot, because the type of flexibility I need to have for the hand, the type of rigidness that I need to have for a leg, all these things, they will deal with the different dimensions. So you need to have a combination of these people who work together. And EEE and EC department people also sit together to have this type of what is that we have it is in robots, and now people are using these robots in the terms of how they use these chips of IoT embedded in the robots also. So the last 2 applications, particularly the Cogito and Boxover, are particularly these 2 applications are pertaining to the customer's behavior. These 2 applications or systems, their Boxover, what they do is they try to find the nature of the customer, like in the terms of how the customers procure the articles. Apart from, they study more, like see a customer has returned a product and the refund for that product has taken more time. What will happen? How does the emotional, how emotional the customer is on all the things like this Cognito and your Boxover are the systems that are developed by your Google and Amazon to just study about the emotional integrity, emotional bonding of the customers. How can the customers, like when I try to wish to product, I wish to buy a TV. In general, I try to search in Amazon. Why this why this person is emotionally connected to this Amazon initially, and what about the longevity and what type of emotional intelligence, what does the sentiment analysis that we can do, and how can we attract the customers to procure things better in this website. So if you could see that, like Boxover will talk about, like every time when you're thinking opening the same, like I wish to procure something called as hard disk. Every time you see the price of the hard disk, sometimes what will happen is, many times you could see here, there is a change of the price, there is a change in the terms of price which is getting reduced, which will infer or which will make you to go for and buy in that Amazon or any other product. This is how it will learn something from you, because you are tending to buy this product. How does the system will have a personalized recommendation system and will help the business to be done. So you need to understand a customer behavior analysis was also done by using AI systems called as Cogito and Boxover. So we have seen n number of applications in health sector and n number of applications on navigation. For your information, I can also tell you, like in Terminator and Matrix movies, we have seen the extent of artificial intelligence applications. But this 30 to 40 minutes of discussion that I wish to have discussed mostly is something about how do you design systems in the terms of deep learning, what type of features are needed, why we need to go for identifying the dynamic parameters for more adaptability and robustness, and have given almost most of the applications that you could find in real time, because you are talking about recent trends of deep learning in the terms of image processing. So then we go to the next slide, like what is the difference between a normal system and an AI system. In general, what does we do in a normal system is, a normal system we try to write the source code, then we try to compile the things, then we try to execute. But in AI, what is that we do is we try to fetch the data, we call it as data sets, then we try to have a machine learning or a deep learning algorithm on that, and then we try to have a predictor which will predict something in future. And if you wish to ask what is the difference between your deep learning or neural network, because deep learning is the way in which you have deep neural networks. So in general, informally, if somebody asks me what is AI, what is deep learning, and what is machine learning, I can say, if you wish to implement the aspects of artificial intelligence, you can implement in the terms of either machine learning, or you can use it. You can implement by using deep learning. So that is what the informal definition is. But there are a lot of differences in the way in which AI thinks and neural network thinks. Like, because AI is more into the design part, and neural network is more into training and testing part. And the representation that we follow in AI is a symbolic representation, and the representation that we follow in ANN is a numeric representation. And it's very difficult to explain the output in the terms of neural network, but we can easily predict and explain the output that we got in AI. And the processing that we could find in AI is a sequential processing, and the processing that we could find in neural networks is a distributed processing, and the fault tolerance is more in neural networks. In artificial intelligence, it's very difficult. But the emphasis of the slide that I kept is, like, most of the people ask me what exactly is machine learning. So what differently we do in machine learning is, machine learning try to learn something from examples, or the ability to learn without explicitly getting programmed, we call it as machine learning. But the most important feature of machine learning is, every time when machine learning algorithm is invoked, or we are talking about designing a machine learning system, we try to design a model which will just fit into the corresponding input and output. So I can say the output of machine learning is a model that can fit to the corresponding input and output. It's a very important observation that you need to have. Every time when you try to design a classifier in machine learning or deep learning, you try to design a model which will suits your, or which will fits your input and output. So if somebody asks me what is the output of machine learning, I say the output of machine learning is your model that can fit for an appropriate input and output. This is also very important because most of the people wish to pursue their research, interdisciplinary research, whatever research that we got, like whatever grant, like I have a recently RPS project that was approved for me, like 18 lakhs project. That is a project that is pertaining to deep learning and metallurgy department. Like we have a mechanical department, we both of them have applied for RPS, and then we got this. Explicitly people try to have deep learning, or explicitly you have some domain of ECE, people are not getting this funding now. In general, I have observed the type of funding that we got it from either SEB or UGC or AICT RPS. The main focus or the main emphasis of the people who are evaluating these proposals are into interdisciplinary aspect. How to use computer science in bioinformatics, how to use deep learning in some other aspect, how does deep learning will enable you to get the output faster and brighter in the terms of accuracy. So everywhere, like we could see, like people in future, like everybody has to know something about machine learning and deep learning. There is no other way for this, because very open problems can be solved very easily by using a deep learning. So we have seen various definitions of artificial intelligence. Artificial intelligence try to mimic the human activities and represent that activities in the terms of system, or AI systems. AI enables the machine to think, and it will just try to mimic whatever activities that are done by a human being. If it is done by a system, that is an AI system. Or if a system, if a system which will process NP hard problem, that is an AI system. A system which exhibits intelligence is an AI system. Many definitions are there, but every time you need to think like whatever activities that are done by a human being, it is trained, then we call it as artificial intelligence. But machine learning is something like it is something about learning from examples. It is something about the ability to learn without explicitly getting programmed. We can relate both of them, like we can relate in the context something like this. So AI systems needs the ability to acquire their knowledge by extracting patterns from the raw data. That ability is called as machine learning. That is how you can relate AI with machine learning. So informally, I just tell my students, like if you wish to implement AI, either you can go for machine learning and deep learning. That's what we will see. But deep learning is a simple aspect. Like deep learning consists of deep neural network. Neural network is a mechanism where how does your brain thinks in the terms of neuron. The same way you represent the problem, how does the neurons communicate. You change the weights based on some conditions. And the interesting part is the most important thing that you need to understand here is when can you go for machine learning and when can you go for deep learning. See, I have 100 images, and in this 100 images, if you are asked to find out how many images are pertaining to car, or how many images are pertaining to vehicle, and how many images are pertaining to humans, then what is that we try to do is we try to find out the number of features to distinguish these vehicles and humans. And it's very easy for your machine learning algorithms to have that features and adopt and find out whether it is a vehicle or a human being. But if I wish to complicate the things, like I have asked you, like I have given almost 1 lakh images, and have asked you to find out what vehicle it is, whether it is a car or a truck or a tractor, and then I have asked what type of human being it is, whether it is a male or a female, or I have asked whether it is an animal and what type of animal it is. My interest is when this type of question was asked, the number of futures are increased and the data is increased. When the number of futures increases to predict something and the number of amount of data increases, obviously machine learning algorithms will not able to give that much accuracy. So you need to go for deep learning to get that accuracy. So I can just tell you, like, when the amount of data is more and the number of futures are more, and your data is not based on the way in which, see, machine learning algorithms will depend on the way in which your data is stored. The representation of data matters in machine learning. So if it does in deep learning, it does not matter. The number of futures increases. So obviously what the deep learning will do is they will go for different types of hidden layers. So for you can have every future, you can have a one hidden layer. If it is, then I can have a different type of structure. So when you have basic features and the limited amount of data, you can go for machine learning. When the data is more, and when you need to have different types of features to find out what exactly it is, then you need to go for deep learning. And this is what most of the people are in this FDP knows, because most of the time you know about what exactly is machine learning, what are the different types of machine learning. And my interest is what are the drawbacks of machine learning, why we have gone through to deep learning, and what are the advancements in deep learning, what are the applications of deep learning is what my emphasis is. So three different types of mechanisms are there in machine learning. It can be supervised, unsupervised, and reinforced or semi-supervised learning. And supervised learning, whenever we wish to go for supervised learning, the meaning is you have data which was labeled. So it's very easy for the algorithm to learn or to predict the output from the input itself. So when the data is labeled, people try to go for supervised learning. When the data is not labeled and your algorithm or your classifier has to find the inherent structure, infer something from the inherent structure, having something like high intra-similarity and low inter-similarity, then we call it as unsupervised structure. And when we wish to learn something from the feedback that we got, whether it is a personal recommendation or when we're designing a robot, then you need to go for reinforced learning, where every time you need to get the feedback. That is the reason when you because I was part of robotics team in various universities and various other labs, whenever we wish to design a robot, we need to just find out what type of actions are permissible. And every time when the action is performed, you'll get an output. We will get a feedback whether the action is appropriate or not. Based on that, the training will perform, and based on that, the validation or testing can be done. So when the feedback is needed, I have to go for reinforced learning. When my data is unlabeled, then you need to find out the inherent structure. We need to learn something from the inherent structure by keeping this high intra-similarity and low inter-similarity. That is what your unsupervised structure is. Supervised learning is very easy when the data is labeled, and we'll have many applications of all these things. So many applications we can talk about supervised learning in the terms of sentimental analysis. Like I said, when you wish to predict the variations of stock market, you can apply this LSTM or RNN, because it is a sequential data. But importantly, then the people will go for sentiment analysis. See, I wish to predict the stock market variations in the terms of processing news articles. I can perform sentiment analysis. The variations in which somebody procures something, you can go for sentiment analysis. Many other applications are there, like you can have a recommendation system, you can have a spam filtering. All these are applications of supervised learning. And you could find many applications of unsupervised learning in the terms of document clustering, anomaly detection. Many applications will be there. Reinforced learning, people, when they try to implement this robotics or personalized recommendation system, traffic management, all this will be the applications of reinforced learning. Just we'll get into the various aspects of supervised learning faster. In supervised learning, we have two techniques. We can call them as classification and regression. And we can say the classification is a process of categorizing the given set of data into classes. And you can apply this classification for both structured as well as unstructured data. And regression is a statistical approach to find the relation between the variables. So you have many standard learning procedures for this supervised learning. I kept very few of them in the interest of time. So linear regression is used when you wish to predict continuous dependent variables from number of independent variables. You can find n number of applications on this. And the most important supervised algorithm, I can name it as a random forest. And the important feature of this random forest is, again, this random forest will support both this regression as well as classification. And if the data is independent, what is that we do in random forest is we can develop the trees parallel. Independent trees can build parallelly, so that the time consumption will be very less, and the model does not fit very easily. That's what the most important feature of random forest, and we'll get considerable amount of accuracy. But if you wish to have more accuracy, you need to build more trees. That will be time consuming. That can be a disadvantage of your random forest. And at the same time, random forest, it's very difficult to interpret the tree that was generated. Like in decision tree is also one of the prominent algorithms of supervised, where I can easily process this decision tree to find out and interpret this trees itself. It's very difficult to interpret a random forest algorithm. So decision trees are the most important, one of the important supervised learning mechanisms, where it uses the tree representation to solve the problem where the leaves can have the classes of the particular problem. And many applications are there pertaining to operation research, decision analysis. Many places, whether in bioinformatics, we have used the decision tree to predict whether the DNA sequences containing protein coding reason or not. Many other applications are there. But I can tell something like the disadvantage that your decision trees have, the small change in the terms of the input will change the height of the tree. Obviously, that destabilize the system to some extent. And the other important supervised learning mechanism that I have reported here is a support vector mission, where the support vector mission, people will talk about this support vector mission when you are trying to address linear as well as non-linear problems. When you try to have a nonlinear cellular automata moving in a nonlinear fashion, we try to address all these problems in bioinformatics, most of them in support, using the support vector mission. So again, this random forest algorithm, decision tree, support vector mission, k-neighborhood algorithm, all these algorithms can be used both for regression as well as classification. But the strength of SVM is, like, many applications will be there in SVM because it can process nonlinear data. But the major disadvantage that it has is it cannot process large data sets, and it cannot give good accuracy when the data sets are more noisy. And the most important applications of SVM can be face detection, classification of images. Most important applications will be in bioinformatics, handwritten recognition. Many applications are there. So my interest of keeping all these mechanisms in the slides is, it's very easy. When the data is independent, then it is better to go for an algorithm called as random forest, which will support both regression and classification. When you have very less data and there is non-linearity in the data, go for SVM. When you need to understand and process or infer from the structure itself, then it is better to go for a decision tree. It depends, like what type of problem you have and what type of solution you need to generate. The k nearest neighboring algorithm is a simple algorithm where it is where the distance metric is used. Actually, see, it stores all the cases and classifies the new cases based on the similarity measure, like distance metric. I said random forest, decision tree, SVM, all the k nearest neighboring algorithm, all can be used for both regression and classification. And mostly the applications that will be pertain to k nearest neighboring algorithm will fall into the forecasting, the economy, and data comparison. How do you predict the petrol prices? How do you predict the gold prices? All this will be coming into your k nearest neighboring algorithm. But my interest of this slide is, when can you go for supervised algorithm? What type of applications will fall into this 1, 2, 3, 4, 5? When can I go for SVM? When can I go for decision tree? When can I go for random forest? Is what my emphasis of keeping this in my slides. So I said, when the data is not labeled, better we go for unsupervised structure. And it is like when you try to have this unsupervised structure, the emphasis is how do you learn something from the inherent structure of the input, keeping in mind that you need to get high intrasimilarity and low intersimilarity. And the most important application that you could find in unsupervised learning is the k-means algorithm. Just a minute. This is the most important. This is the oldest, and still people are working in it to produce various different type of classifiers for their own problems. K-means algorithms has n number of applications. The reason is k-means algorithm can process large data sets, and it can adopt and it give higher accuracy for a new unknown cases also. It's a k-means algorithm is a simple and most popular algorithm in unsupervised learning, where what is that it will do is it will try to identify k number of centroids, then allocates each data point to the nearest cluster. This is what the strategy that they use. But the major disadvantage that k-means algorithm will have is it's very difficult to predict the k value. And the small disadvantage that you can think about this is rescaling the data sets will have a significant change in the accuracy of the classifier. But most of them still use this k-means algorithm, because when you process data sets pertaining to images of crops or any other bioinformatics DNA sequences, the data sets will be in lakhs. So I need to have a classifier which process large data sets, and I need a classifier which adopts to the new examples. Then I will go for a k-means algorithm, which is the most important algorithm with more number of applications like document clustering, image segmentation, image compression, and so on and so forth. So this, I feel, among all the 4 that I have cited here, this is the most important application that we have discussed. Then we have hierarchical clustering, the most important clustering algorithm that is attracts to this unsupervised learning mechanism, where many applications in the terms of biometrics will come in this hierarchical clustering. And the advantage that it have is the structural importance, like you can inherit most of the information from the structure itself. But the disadvantage is it cannot process large data sets, and it is also sensitive to outliers. When you wish to go for large data sets, go for this k-means. When you have less data, and apart from that you need to learn or infer from the structure itself, then you have to go for this hierarchical clustering. And you could also see this Pca and a priori algorithm also was kept in this slide to tell you that all these algorithms are your Pca algorithm is a statistical technique to examine the interrelations among the set of variables. So obviously this is a statistical structure. So we have applications like facial recognition, computer vision, and when you wish to compress the image, we go for Pca. And most of the people know this a priori algorithm. A priori algorithm will be used in data mining to predict what type of things that a person can procure. Like I wish I procure a bread in some place in a store, and with bread what type of other frequent data items that I can procure. With bread there is a chance that I can also procure jam. Once I procure jam, there is a chance I can procure milk, and so on and so forth. How does you relate the frequent item sets? We call it as a market basket analysis, is what the application of API algorithm. And API algorithm is into unsupervised learning structure, because the data is not labeled and you need to get the inherited extraction from the input data itself. So we have many other unsupervised learning mechanisms that I have not listed here. A few of them I have listed. The interest of that is, like, many applications are there. Many of the applications will force us to go for this unsupervised learning. And now I wish to go to the earlier slide telling you what exactly will be the drawbacks of machine learning. That is the reason we are going into, we call it as most important, the part called as deep learning. So when I have been taking classes to a university called as Kufa in Iraq, one of the participant asked me a question. It looks like a simple question, but it has some inference in that question. Like, he has asked me, is it easy to perform arithmetic operations on Arabic numerals, or is it easy to perform arithmetic operations on Roman numerals when I am using machine learning? That's what the question is. That question has a lot of in-depth analysis. The question is talking about how does machine learning is dependent on the representation. So the answer for that question is, you can easily perform arithmetic operations on Arabic numerals. It's very easy to perform that than Roman numerals. The reason is the representation of Arabic numerals are very easy, and your machine learning algorithm can process this Arabic numerals very fastly than Roman numerals, because machine learning algorithms are dependent on the choice of representation of the data. I need a mechanism which does not depend upon the choice of representation of data. That mechanism is called as a deep learning mechanism. Apart from that, I said, when the data is more and when the number of features to identify the things are more, then you need to go for deep learning. That is the reason we have deep learning, which solves the central problem of representation by introducing various representations that can be expressed in the similar representations. When the number of features are there, it is better you go for a similar type of hidden layers, and it does not depend upon the way in which you store things. How do you represent? Representation is not the bother of deep learning. So that is the reason we are just moving into the slide to know more about why we need deep learning. You could see here, most of the standard machine learning algorithms, the performance is like a plateau. When the amount of data increases like this, the performance is a statue, it is a constant throughout. But you see the deep learning algorithms here, when the amount of data increases, this I have taken from a standard textbook, I have referred this in the reference also. So when the amount of data increases, obviously the performance of the deep learning methods will increase. When you represent the problem correctly in the terms of the neural network, deep neural network, then obviously the performance increases. That is the reason this is a transition point where people try to apply most of the problems in deep learning. That is why the emphasis that I said, most of the first part of my talk is biased towards deep learning applications only, because most of the advanced, whether I talk about Cognito or Deep Power or what are the latest happenings that were done in deep learning, the reason is the performance in the terms of how the data increases. Because whatever machine learning algorithms that we develop, they need to process big data. Then this big processed data in generally will be stored in your cloud. So it's all are integrated. This machine learning algorithms and deep learning algorithms, your big data analytics and cloud computing and IoT, all these are integrated. So everywhere we talk about smart things, we talk about deep learning and IoT. When we talk about big data, we use the same data, deep learning algorithms and process the big data and store things in cloud so that the usability of the data is more and visibility of the data is more. So that is the reason this is a transition point where people try to move from machine learning to deep learning to see that the performance is more when the data is more. And the performance does not depend on the number of features. And deep learning, if I wish to introduce deep learning like this, deep learning can learn from unstructured as well as structured data as well as unlabeled and labeled data. It can contain many hidden layers. We could see the picture like deep learning can process audios, videos, text, and this is just to tell you, like most of the application that you could see, like if an application wish to be developed in AI to process images, now they are going for CNN and a combination of RNN. And audio and text and video, most of the time you could see the applications in the terms of deep learning. I'm just seeing the watch and it is 3:30. Okay. So this diagram was kept to just tell you, like the number of hidden layers will increase with respect to the number of features that you add. And the next slide shows you the most important mechanisms that we could find in deep learning. You can start with single perceptron layer, and you have multi-layer perceptron model. Many other models are there. And just try to give the overall view of that, and I just conclude. This is my last slide. It is. So you have various deep learning models which we can choose in the terms of what type of application you have, in the terms of what type of domain you are using, and the amount of data that you have, volatility of the data, time sequencing data, different types of data you have. Based on that, you can choose the appropriate model. If you wish to start with the various deep learning models, you can start with a multi-layer perceptron model, which was not written here, where this multi-layer perceptron model has n number of applications, where this multi-layer perceptron model will be in the category of feed-forward networks, where this can have at most 2 hidden layers and have n number of applications as image reconstruction. Like I need to find out whether the image is original or not. Image reconstruction, speech recognition, machine translation, and data classification. And most of the e-commerce application that we could find online are all these are applications of multi-layer perceptron model. And I feel this is a basic model, and it has to be known to you. The reason is we have n number of applications of this MLP. Then we could think about RNN and LSTM, recurrent neural network. Whenever people talk about recurrent neural network, they're talking about data. We call the data as a time series data. Time series data is just data that is in a sequence. Like a sequence of words is a sentence. A sequence of sentence is a language. So when you try to process this type of data, you can go for RNN. The interesting feature of RNN is it uses some internal memory to store the variable length of input. When you need to store this in a large context, you can go for LSTM, because LSTM is an extension of RNN, long shorter memory. So I said stock market because many of the applications of LSTM will get into stock market, because stock market data is a time series data. Even people are using LSTM to apply the sentimental analysis also. So when you have a sequential data with you, then you can go for either RNN or LSTM, and you have a number of applications for that. Whether like you talk about sentimental analysis, or whether you talk about various classifications, natural language processing, all these are applications of RNN, machine translations, video classifications, and many other things, handwritten like recognition. All this can be the applications of RNN, and RNN LSTM. We could find many applications pertaining to this, both of them. I said LSTM is the what extension of RNN. It is also RNN is basically, I said MLP is a feed forward network, and RNN is a recurrent neural network which uses this back propagation strategy. And LSTM can be used for stock market prediction, customer behavior study, and sentimental analysis, changing of market trends, many other things which are sequential. And you already have a knowledge on what exactly CNN is. CNN uses this feed forward network, and many applications are there. When people try to process audio or video or image, generally people will use this CNN. Now you could see many papers, the combinations of people are using CNN and RNN, and now there is a concept called as TNN, an energy efficient neural network, which is which most of the people are using with a combination of CNN to have a better output. So many examples of CNN can be there, because CNN, if you wish to me to talk, CNN will take almost 5 to 6 hours. You can talk in detail, because CNN research is infinite, and the amount of depth that CNN has is infinite. It will take days to discuss about CNN. Many applications are there in CNN. In the terms of image processing, video recognition, natural language processing, pattern recognition, medical image analysis. That's what we are talking about. I'm talking about how does your COVID X-rays are scanned by using CNN, and all this are what the applications of CNN. And other many other different types of mechanisms are there. We can talk about GAN or RBM or DAN. It depends upon how do you choose. You have an unsupervised structure, then go for structure, then go for a GAN. You try to have keep this probability here. Both of this RBM and DBN will be pertaining to probability. GAN is a generative adversarial neural network, which is unsupervised structure, where most of the people who are working in cyber security, health diagnosis, and NLP, speech recognition, all this will be done here. Actually, most of the people who are working in cybersecurity, they use this generative adversarial network because it's unsupervised structure. And health diagnosis, most of this is GAN. Now people talk about Watson. They are using in Watson. Now they are using this GAN. So RBM is again a restricted Boltzmann machine. It can learn from probability distribution over a set of inputs. And many applications of RBM is there, whether you talk about recommendation systems. A most important application of RBM can be topic modeling. People are working on this topic modeling towards the research. And recommendation systems, and n number of applications are there. Again, this deep belief neural network will fall into your unsupervised structure. Well, we wish to have this image and face recognition. I can use this DBN. Video sequence recognition, and when there is a fabricated video that you have, whether you need to find out whether that sequence of images that you get as a video is right or wrong, we go for DBN. And motion capture, and most of the applications are there. It depends upon this. This slide is only kept to just give you overview of standard models and mechanisms that we have in deep learning. And I wish to tell you the applications and domains where you can use, because whenever people try to think in the terms of cyber security, they will get into GAN. When people try to have a sequential data, then generally people will use RNN and LSTM. People try to process voice, audio or video, definitely they use CNN, because the convolution that it have, the ReLU and the overlay and all the other things that we have in CNN to explain the structure, it depends upon the way in which you represent the problem, the way in which you change the functions and get the output. And whenever people try to think in the terms of topic modeling in general, people now they are thinking when they go for RBM, when people try to find out whether the video that they got is a fabricated or not, then people try to apply this deep belief neural network. All these last two are pertain to the probability distribution models, and some of them are feed forward, some of them are back propagated strategy, some of them are unsupervised. My interest of keeping this is to just introduce you this type of models are there, you can use these models in this type of domains. And then these are the references that I have used to just procure some information, and this is what the disclaimer that I have given for every webinar that I am having. All the images and contents which are presented here are just for non-profit educational purpose and not for any commercial use. This is what we are asked to have it for every presentation. And thank you very much. If you have any doubts, please just type something in the chat box, or you can unmute yourself and you can have a discussion.
Kiran sir, questions are posted in the chat box. Kindly refer, sir.
Just I'm going through the questions, madam. For unsupervised, why we need to select GAN? GAN is a generative adversarial neural network. In general, the nature of that GAN is inbuilt unsupervised structure actually. See, it depends upon the nature of data that you need to select an appropriate classifier. That is how you to see. If the data is labeled, then you need to choose one classifier. If the data is not labeled, then you need to choose a different classifier. That depends. Different type of deep learning neural network. How do you select deep learning for image processing applications? Example, disease diagnosis. See, whenever people try to have something about processing of images, the first thing that we will keep in mind is to use CNN, because I said many different type of applications are there to process the X-rays of patients. Then your disease diagnosis, if you use CNN, most probably you'll get a more accuracy than any other classifier you'll get. That's what the answer for this question. And I have seen only for video processing, which deep learning architecture is suitable. Most of the time when we try to process videos, it depends upon what is the functionality of that processing. Like, are you going to predict whether the video that you got is right or wrong, like video sequence recognition, whether the video that you got is the original or not, then you go for deep belief network. Or when you wish to process the video and just find out the abnormalities on that video, then you can go for CNN itself. It depends upon what is the end product. Based on that, you can select the corresponding deep learning architecture. The best thing you can do is you can take DBN or you can take CNN. That's what my answer is.
Yes, sir. Sir, this is Maheshwari.
Madam, please.
Yes, that is my question, sir. Why all peoples are interested only in CNN? What is the specialty in that? How it is producing better results as compared to other DLNN, sir?
Why people are more interested in using CNN? Is it right, madam? That's what it is?
Yes, sir. Yes, sir.
The reason is the adaptability of the classifier, because I can say at this moment without CNN, it's very difficult for anybody to produce classifiers with the highest accuracy, because the way in which the convolution function, the overlay and ReLU functions will change. The only thing that you need to keep it is how do you represent the problem, because CNN is inherently very strong and robust. That is the reason, if you could see, for CNN itself, we have a textbook from Pearson Education that was written by Agarwal from Central University, Hyderabad. Only a deep learning with CNN is a textbook with almost 250 pages, which is only talking about this mechanism called as CNN. Until unless you just try to implement this, the way, see, you implement basic image classification by using a small machine learning algorithm, and you implement this by using a CNN, you could find the difference in which the flexibility that you get in the terms of representing the problem, the flexibility that you get in the terms of accuracy and everything. It has a self-adjustable property also. That is the reason CNN has its own advantage and have its own advent in the terms of accuracy, in the terms of the less training that it can take, and the way in which it can predict from processing few examples itself.
What is the main function of Rayleigh function here? It is similar to our weights or some other process?
Madam, I think most probably your voice is not reaching, madam.
Sir, Rayleigh function, the function of Rayleigh function. Now am I audible, sir? Am I audible, sir?
Now you are audible, madam, please.
Yeah, sir, the main significance or what is the Rayleigh function, sir? It is similar
Okay.
to our...
You are talking about Rayleigh. Rayleigh is something called as rectified linear unit, madam. Actually, Rayleigh is referred as rectified unit. The most common thing that Rayleigh will do is something like this. It is a commonly what is that we can commonly used activation function in the terms of CNN neurons. If you wish to have something like I can say Rayleigh is one of the convolution function that you apply in CNN, madam. That's what I can tell you.
Okay, sir. Thank you, sir.
Please.
Scale, sir. Any other questions from audience?
I'm
I think there is no
finding the
questions in
questions.
chat box. Scale, sir, are you here?
Yes, ma'am, I am here.
Yeah. Yes, sir. RMK ma'am is there.
Yeah, madam
Ma'am,
is here only.
ma'am, shall we wind up the session, ma'am? Okay, sir. Scale, sir, you can continue. Continue the vote of thanks, sir.
Okay, ma'am. Good evening, one and all. I am XK Logesh, Assistant Professor, Department of Tripoli, Kongu Engineering College. I feel happy to propose the vote of thanks for today's session. I would like to thank Principal Management of Kongu Engineering College for permitting us to conduct this 5 days FDP. I would like to thank our head of the department, Dr. R. Meena Kumari, for her constant guidance and support in all our activities. And also I thank her for introducing our chief guest of today's session. Thank you, ma'am. Next, I like to thank our today's speaker, Dr. P. Kiran Sree, Professor, Department of Computer Science and Engineering, Sri Vishnu Engineering College for Women, Andhra Pradesh, for wonderful session by sharing his knowledge in deep learning. Thank you, sir.
Thank you very much. Please.
I thank all the participants for their active participation in today's session. Thank you all. Thank you. Participants, fill the feedback form, which is posted. The link is posted in the chat box. Thank you.
Kiran sir, thank you very much for accepting our invitation, sir. And you're taking 2 hours almost, I think so. 2 hours. Thank you so much, sir, for your session.
It's my privilege, madam. It's privilege talking to you all, and it's happy to be part of this FDP, madam. and I think in future also we will collaborate for this type of events. Thank you very much, ma'am.
Definitely, sir. Thank you, sir. Thank
Thank
you
you,
so
madam.
much.
Have a nice
Thank
day.
you all.